Hello everyone, it's AStar Games. Today we will be adding AStar logic to our game and make an NPC, a monster, to follow our player. This will be the end result where monster follows the player. To get this result, we need to add an library. For this I am using Defold AStar from Selim Anaç, and I will leave this to the comment section. You need to copy and paste it to dependencies. And after that, go to project, fetch libraries, and it will fetch the libraries. Then we will go to our main collection and create the monster. First on the collection, press A to add a game object, name it monster, right click, add component sprite. On the sprite we will need the monster sprite. That's why we will first create an image atlas, right click to resources, new atlas, name it image atlas. On the image atlas, right click, add image and select the monster image you want to use. Close it. On the sprite, go to image and select the image atlas, and on the default animation, select the image you want to use. Then right click, add component and collision object. On the collision object, set the type to dynamic and right click, add shape, sphere. On the sphere, set the diameter to something around 10 or whatever you want. After that, we will need to create a script to control the NPC, the monster. But for this, we first need to create an module, AStar module, so we can access it. Right click to the scripts, add a new Lua module, name it AStar. On the Lua module, we first set the tile size to 16 because I use 16 by 16 tiles. Then create an empty table named fill tiles. We add a function named isTileEmpty that returns if a tile is empty or not. We have a function to mark a tile as empty, where we enter tile coordinates like 6 to 5, then it returns where it is placed on the map. Then we have the setup AStar function. We create a table named map to hold the walkable and non-walkable tiles. Then we get the ID of the tiles on the tile map and save them on the table named tiles. We iterate through the table, and if a tile's ID is 17 and it's empty, we insert it to our map and with the value of 1. If not, we set it to 0 to show it's unwalkable. The reason why we selected 17 is because if I go to my tile map and go to my 17th tile, this is the tile where player is able to walk. That's why I use 17. If you have a different tile map, you will have a different value here probably. Then we make the AStar configurations. On the direction, you can have a direction 4 or direction 8. Direction 8 also enables diagonal movement. If you only want to be able to move horizontally or vertically, you can use direction 4. Then we set the allocate to map width and height. These are the values suggested on the example project, so I didn't change them. Then we set up the AStar with the values and set map with our map table. Here we set the costs. This is the east, north, west, and south. The first 4, then the next 4 is the diagonals. If you have different walkable tiles and maybe walking on one of them is more difficult than the other one, then you can set them with different values, and on the cost you can set higher values to the correct ID to have different tiles with different difficulties to walk on. Then we set the cost. We also have a function named find pet. We give the start and end positions, and it returns us a solution if there is any. AStar.solve returns 4 value. That's why we created 4 values. First the status, then the size, total cost, and pet. We don't really use size here, so you can put underscore if you want. If the status is solved, that means there is a way we can follow to get to the endpoint. So we first create a table named waypoints, the points we need to visit. Then we use a for loop to iterate the path and save the value to tile. The first return value on the path will not be used, so we use underscore to discard it. We will use the tile and set the correct x and y value on the waypoints. After that, we return the waypoints and the total cost. If the status is no solution, that means either and or start position is not on the walkable tiles. If the start and end is the same, it also will print it and return nil. We have this return which basically says when someone uses this module and try to access find pet, then you will understand it as this function. So you can have maybe find new pet equals to find pet, and it will work. After that, we go to our main collection. We need to attach a script to our monster as well. So right click to the script, new script, name it monster NPC or maybe follow logic script. On the script, we again set the tile size, set a speed value, and set a requirement for the AStar module. We have two functions. First one is used to convert screen position to tile coordinates, and the second one does the opposite. On the init, we get the map width and height from the tile map.getBounds. This returns 4 values. This is the first x and the first y, last x and the last y. We only need the last one, so we discard the first two. Then we use the AStar module to set up AStar. We enter the map height and width, also give the correct path to our map with the correct layer. We will be using the ground layer. Then on our self table, we create a variable named target and target index. We also create a current path table on our self table. Then we basically do the same with what we did on the AStars. Set up AStar. This kinda seems pointless, but when you delete it, the monster, the NPC gets stuck easily. To avoid this, we need this part as well. On the update, we get the player's position and our position. We use screen to coords to get the tile we are on and save them to x and y value of the correct variables. Then we check if we don't have a target or our distance to the target is greater than 1 tile size. Then we check if we don't have a pet currently or our target index is greater than 0. I have added this check to stop NPC from calculating too often when player is moving and always staying at the same position till player stops. We check if it's greater than 3. Then we use AStar.findPet to check if there is a pet. If there is a pet and the pet size is greater than 0, when you use this sharp in front of a table, it returns the size of it. If it is greater than 0, then we set the current pet to the returned pet. We set the target index to 1 and the target to the position of the last point on the pet. Since we set the pet here, then we check if the current pet length is greater than 0 and our target index is less than the current pet's length. Then we use the target index to get our next tile, the tile we want to move. Using the next tile, we find the next position using coordinates to screen. Then on the direction, we normalize the direction we want to go. After that, we set it to move. If we are close enough to the position we want to be on, we increase the target index to go to the next tile we need to move. And that's it. That's how you can add AStar follow logic. There is a slight problem though. If you are on a tile but the tile's ID is not 17, we cannot work on it. Then, as you can see, there is no solution to it. But when you are on the 17, it will continue to follow again. The reason why this is happening is because collisions are allowing me to be on tiles other than the tile 17. So I need to change this. Then I will open the image I used to create collisions to my tile map and open with Sprite, or you can use Paint too. And I will just leave the tile 17 empty and fill the rest. After that, when I try to go to up and down, I won't be able to, so the monster will always be able to follow me. And that's it. That's how you can add AStar follow logic to your game. I will save this project file to my itch.io page so you can download it. If you have any question, you can ask me on the comment section and you can find the project link again on the comment section. Thank you for watching and have a nice day.